Yeah, so that's the, there's only 2 solar panels here for the winter. They're angled for the winter sun. Usually I have all 6 up on the roof, which makes 600 watts of solar panels. 3 of them wired into one charge controller, 3 of them wired into the other charge controller. That way it divides the load, and then they're wired up in parallel. So the winter setup, of course, is a little bit different than the summer, as I said before. But these are the 2 main charge controllers. So 3 panels will be coming through each one of these. And so through that, and you can see here what the readings are in the charge controller. So we have 14.3 volts in the battery, which means it's full capacity. A little battery indicator tells you that it's got lots. We're using 0 watts right now, surprise, because nothing is on. So we're not really requiring any power. So 2 charge controllers. They are wired into the fuse box from my old car, because it's a 12-volt fuse box, so it's the same thing, through a 60 amp fuse, which runs into, so 2 charge controllers into 60 amp fuse, out through the cable that leads to the batteries. And so it comes down here to 2 RV batteries, which I never run down at all. So those are wired in. They are wired again in parallel, so you get 12 volts higher amperage, and that's why we have these cables crossed like that. So you can see the quite heavy cables. This is like a 1 gauge or 0 gauge in the American system. Quite heavy cables coming off of the battery bank. And normally I have, in the summer, I have an inverter sitting right here instead of a jug of soy milk. And so the inverter, and with a 250 amp circuit breaker. And so that's if everything, if it's overdraws, something wrong with the inverter, starts to destroy the system, the circuit breaker will blow. It also tends to go when I'm out there using the chainsaw. So this plugs into the inverter, goes into a regular kind of circuit breaker you'd have in a house, 30 amp AC circuit breaker. This gives me the AC power here, and is also, this plugs into the inverter and goes out through the wall, and I have a box on the outside that gives me AC power as well. So wires lead from here, remember this is alternating current, here, and up here, and over here, and we get into the AC wiring system for the rest of the cabin and elsewhere. So AC power, as you can see, AC power that goes to the workshop out through this cable, and that I can turn off and on. You don't want power out there all the time. If there's like some kind of problem, you want to be able to shut it off. So that's AC power to the workshop. This is DC power to the workshop. These are simple, just knife switches, which I've labeled on and off. There's also a fuse that takes us to this fused receptacle and to this wiring system. It's joined into this wiring system. And also, from the fuse box through the 220 amp panels, we have wiring leading into this main fuse system, another fuse and system. I have fuses everywhere. The main switch that shuts off all DC power in the entire cabin, and 2 ammeters, because I don't quite trust either one of them, that measure how much amps the whole cabin is using at any given time. So I had a drill that was dying. When I was starting to use that drill, it would peg at like 10 amps, and I knew the drill was almost no good and was drawing way too much power and doing too little work. So wiring through here, up through here, along. Part of it goes through the wall here somewhere. Yeah. Anyway, so along here and down to this box. So I took this out of an old inverter. I just cut out the piece where you plug in things, and that's a DC wiring system here. And there's another DC cord comes off of this line and goes into the wall on the other side. There's also this cabling, which comes from over there, the same kind of wiring configuration mess you saw. This cabling goes through the wall here and supplies the new part of the cabin. So it gets a bit complex in here, but we have a 12-volt line coming through here to a junction box, and that junction box feeds this receptacle, so that's a 12-volt receptacle. Nice thing about the modern Edison receptacles is they have the big spade and the little spade, which means that when you plug something in, it has to go in only one way. Real annoyance for the homeowner, very handy if you've wired AC power to DC, and quit smelling your fingers. And so there's that one. And then this is a DC receptacle of an older vintage. Goes into this little panel I took off the back of a stereo, which feeds the power to this thing, which gives us a USB, also regular car kind of receptacles here. So that's that system. We have a wire coming from there over here and feeding the 12-volt light. And there's a switch near the door that turns that light off and on. A switch I took out of like some device or other. I think it was a charger, battery charger. Alright, so that's that kind of wiring system. There's a bit of a wiring system built into the cabin, as you can see here, and which is the 4-volt system, which runs off of a small solar panel I have outside and a small dustbuster battery, which runs little lights like this one. So I've got a few of those scattered around, and they're kind of wired into the cabin system. Also, we come over here. This is another one of those 4-volt lights, but we have wiring coming through the wall and feeding this receptacle, and which there's 2 wires coming through, well, 2 sets. The top one is actually AC and the bottom one is DC, which I think would be very confusing for your regular homeowner. And so the DC line goes to this inverter that comes from a device I tore apart, and uses an inverter, nice clean signal inverter. And then the top one is straight AC, and I can use it for like 120 volt AC devices in here. So this 12-volt line coming again off this thing I got off a stereo runs through here past like the 1950s icicles, and then down into a it's a voltage regulator, a small voltage regulator. That's what it looks like, a 3-point regulator, which is actually running a bit hot. Ooh, yeah. Anyway, so voltage regulator, and that's a 6-volt, and that comes up to this device, which used to be a rechargeable 6-volt device, but is now wired into the cabin system with a regulator, and that runs this little light here, as well as the radio. And then this is the regular 4.5 volt system that we've talked about before. The 12-volt wire continues over here and is wired into this light, which is of kind of indifferent quality. I got it out of a like a kind of battery backup device, and that's just in case you need light here in the kind of kitchen area. So we're going out to the next room now. I call it the new part. The new part. The term becomes increasingly less important the older the building gets. You can see the plumbing system runs through here, which is partly garden hose and partly copper joins. And again, like, copper joints, I got other junk. And this is the electrical system. So the orange cable came through the wall and joins up with this. We have an AC cable coming down here, which this one is the AC. I don't have them labeled, but I just kind of know. That's the AC line, and this is the DC line again. And there's a join for the DC line here. There's a cable here that goes out to the greenhouse, and there's a receptacle on the wall out there as well, which is the DC line. Why is that hung like that? Anyway, so and there's also a receptacle over here, which is DC line receptacle, just for convenience sake. And there is the 12 volts line goes from that plug through the wall. You can't see it because it's underneath the wall. To this light, which I made out of an antique bottle and some LEDs, which is actually much brighter at night. And it looks kind of interesting and strange. There's a DC plug over there as well. And this is a cordless 12-volt drill, which I have wired to a corded 12-volt drill. And you can plug it into any of these receptacles and you've got power. Likewise, this is a 12-volt LED bulb that I have wired into a regular lamp that I made out of a shipwreck piece. And it also runs off a 12-volt. But unfortunately it's blue. My friend gave it to me. It's from a car, but it's really blue, and I don't know that you'd be reading by that at night. Okay, so Mr. Bear, you what do you have in your hand? It's a circuit board out of something. But what I want is that chunk of aluminum, and because we're going to use that as a heat sink for the 6-volt regulator inside, and then it'll run a bit cooler. So here you can see I've got a bandsaw, and the bandsaw is a 120 device. That panel that has the two receptacles and it's black is the AC line. So the yellow wire that comes out of that goes down into the floor. Runs from the cabin underground, and gives me both AC and DC actually, because there's 4 wires in the cable. And so the DC line is that gray set of receptacles stuck on the wall. I tore it out of an old voltage regulator. So I can run any of my 12-volt devices out here. I can run a skill saw for AC and any of those devices as well.